è levato via col
l'altro giorno non mi sono fermato.
Video già non vedo.
Sì, ho visto. Che dopo posso
like a submission to committee. Yes.
It's fine. Can you see it from there? Yeah.
No, posso metterlo.
Sposta pure se vuoi Gabriele.
Ok.
I think we can go with the order that, yeah? You can start.
No, because here we are live.
Not yet. The video has been removed from the video.
But here I'm live.
Yeah, okay. And maybe I change the
I think we can keep the order we are here.
Okay, I search here.
And yeah, project we have discussed the way. It's really fast. So go with the order we have on. Slide to worship.
Full what?
To the worship. The slide to the event.
Yes.
We have.
Slides for the event.
Yeah. No. Maybe we have.
I think just going to seize the microphone. It's not working.
Can we go? You can't hear anything?
No, not very clear.
Can we go now?
Yeah?
Yeah.
I'm sharing. Are you connected?
Yeah. It's better.
Set your name.
Okay.
Okay.
Lock it. No, wait. Lock it. Okay. Keep it locked.
You just the first.
Okay, we can get it closer. Good.
It will fall, trust me.
For what? Yeah, you can open it totally. Okay.
But I don't think they have No, yeah, can you put on? Can you put on a book? You should do that. Also, you can use that box.
It will fall.
I think it's fine.
And be sure that you speak for. Where this line come from? I think so.
If you change the slide,
It's supposed to be optimized for something.
even now.
Or that was? Just the cable of the...
No, why? This is not important.
Can you try to do the test?
Fine?
Yeah.
find?
No, these are the security implementation. They want some.
The one that goes but the problem is that I was hearing myself having really good people.
Okay, so welcome to 2017 edition of the SPRITZ workshop organized in collaboration with CLUSIT, which is Italian Association for Computer Security. And this is an event organized in the framework of the European Cybersecurity Month, and it's kind of organized by our group, but also supported by the Department of Mathematics, the HIT Human Inspired Technology Research Center, and the Target Smart project we're involved in. And this workshop will feature 4 presentations. So the first one will be given by Chagan, which is a postdoc in our group, so in the University of Padua, and actually his talk will be to present you the ongoing Target Smart project, which is on basically IoT, and our group is taking care of the security aspect of this project. And then Stefano Cazzalara, which is a postdoc at the University of Venice, is going to give a talk on control relaxation of content security policies by runtime policy composition. And then the last 2 talks will be by Vinod, which is again postdoc at the University of Padua, with an interesting talk titled "Can Machine Learning Be Secure?" And finally, Mohammed Shajafar, CNIT senior researcher at the University of Rome, Tor Vergata, is going to give a talk about lifetime aware, fault aware, energy aware SDN and CDN, optimal formulation and solutions. So hope you will enjoy the workshop. Let's keep it alive, so feel free to interrupt the speakers, ask questions, and have fun.
Hello everyone. So I will talk about Target Smart. It is a European project in which the University of Padua is involved. So Smart Tag is about smart tags, of course. Target Smart is about smart tags, which derive the service platform for enabling the ecosystem of connected objects. So in this project, we are targeting the mass products, and when I say mass product, it could be a piece of meat, it could be a bottle of milk, it could be a bottle of Coke, beer, anything. So, and when I say that we are talking about the products, I must say that we are talking about individual product. We are not talking about group of products. For example, there could be a carton full of milk bottles, and so we are not talking about the carton. We are talking about the individual bottles inside the carton. So the question is, do we know their story? So here again, story means not the description of the product, or you can say that consists of the ingredients by which the product is made of, the company that is manufacturing the product. So story doesn't mean that. We already know, we already have this technique. You can scan the barcode and you will know these things when you scan a product. So when I say, do you know their story, I mean that do you know their story from the manufacturing point to the point they are thrown in the recycle bin. So I'm talking about that story, and I'm talking about the story in terms of the environmental conditions to which they are exposed from the start point to their end point. So of course we don't know their story, because for example, we go and buy, let's say, ice cream. So we don't know that from the point of the manufacturing of that particular ice cream box, whether it is been exposed to undesirable conditions before we bought it. I mean, from the point of the manufacturer till we bought it. Did that ice cream box has been exposed to undesirable environmental conditions like high temperature? So we don't know that, but we want to know that, because if that is the case, then it might be possible that the ice cream, eating the ice cream is harmful, or maybe it changes the actual taste of the ice cream. So we want to know whether that is the case or not. So that kind of story we want to know about these mass market products. And how we know it, that is the project, Tag It Smart, by using the smart tags that will be put on these individual items, so that those tags could speak up. And when I say speak up, means they can tell the story of that product through its lifetime. So we let them speak using the smart tags. So the smart tags tells you whether your product comes from scorching hot or it comes from a cold and fuzzy ride. So the overall objective of this project, as I already told you, is connected mass market products with unique identity. So each product will be uniquely identified in this system, and that can report on their environment. So the vision is you use the functional link and printed MC to create the or to print the smart tags, and then use the crowd-sourced readers that will read this smart tag to know the story of the product. And then you use the information. When I say information, it could be the information that is in the smart tag when you read it, or it could be the contextual information. For example, the location where the tag is read, the time, such kind of contextual information that could be used or that could be sent by this reader along with the content of the smart tag. So all that information will be put at the cloud, and then we create the IoT for mass market domain. So for example, if you buy or if you scan a bottle of wine, then it might be possible that when you scan it, that information goes to the cloud services, and it might be possible that some service provider will give you other options for different wines, because he knows that you would like to purchase a wine. So he could give you information about other wines. He could tell you if there are any offers on the wines. So this could be done by using the data that the consumer or the customer has read using the smart tags. So of course these all services could be generated and provided to the customer as, you can say, value-added services, and that whole concept will then can be turned into this IoT for mass market domain. So in short, we have smart printed tags which could be read by using a reader that will run on smartphones or any other mobile device. Plus we have cloud to process the data that we scan from the smart tags or the other contextual data related to the customer. And by combining these three, we go for IoT for mass market products. So who will benefit from all this, putting the tags and reading them, and how? So of course manufacturers, because they are able to control products through the life cycle and create a channel to communicate with the customer and other stakeholders. So manufacturer is able to know that in the logistic chain at what point story for each product, and also they could get new services if they agreed to send additional information along with the product information that they are scanning. So they could also get additional services, plus then they can authenticate the product by using the information that they read, and they know the conditions in which the product is kept before it is put in the retail store. So in this project, we have 15 partners. We have large industries like Siemens, Fuji, Unilever, and then we have small SMEs like Rust, Ecom, Thin Film. These are the printing companies, because of course we are printing the smart text, so we have printing companies, you can say. And then we have end users like, again, Unilever, Uniexport, it is a big meat company in Siberia. And then we have research. We have VTT Research Lab from Finland, University of Surrey, and University of Padua. Okay, so more about these smart tags I'm talking about. So smart tag encoding. So you can use data matrix code with sensor area. So now we are using the 3rd generation data matrix code. Plus you can use dual QR code. In this we have one QR code and then we superimpose another QR code. But the difference is that we already have QR codes, but in this case the ink that we are using for the QR code is called the functional ink, and this ink can be you can say engineered for certain purpose. For example, this ink might react when it is exposed to certain temperature or certain pressure. So it could react to the environmental conditions. So this is the functional inks that we will be using to create these tags in the project. Then we have other combinations that we can use, like we can use QR code combined with the image, and we can use multiple functional links in a single QR code to create the smart tags. So this is how we can encode information in the QR codes. And these are few examples that we are using in different use cases in the project. We have lifecycle management, then we have digital product. This is we are using for the beer, and then we have dynamic pricing. This is we are using for the meat. So if, for example, if the meat is near to the expiry date, then its price could be dynamically changed. That is, of course, it could be lower as compared to the initial price, so that it could be sold before the expiry. And plus, in this, of course, the temperature is an important factor when it comes to the meat, because it should be put at the right temperature. So they are using also the smart tags that would react to the temperature. So this is what we are using in this particular use case. Then we have home services use case and the brand protection use case, in which this is mainly for resisting the counterfeiting of the products. Then we have, of course, we have the tags. Then we have to scan those tags, and for that we have the FC scanners. We call it FC scanner that will scan these smart tags. So this is a software that could be run in any mobile device, and through that software you can interact with the smart tags. Okay, so this is the top level architecture. We are mainly focusing here, in which we have the enabler, scanner enablers, that is the app that will scan the smart tags. Then we have identity manager enabler, and this will keep track of the identity of the users as well as the products. And then we have context manager enabler. So we have a big role of the contextual information in this project, because as I said, that this contextual information that is collected at the time of scanning could be used by various service providers to provide additional services to the user when he is scanning a product. So of course, to use the context, we have to first collect the context. So in our case, we use context for two purposes. First, as I said, for additional service creations, And also we are using contextual information to enhance the security of the user mobile applications plus the data, user data that is stored in the mobile device. Because as I said, that this scanner enabler application, which is used to scan the smart text, will be running on the mobile devices. So of course, for this case, we have to take care of all the security threats that could be done with this, that could be done to threaten the functionality of this scanner. Okay, so we have scanner, then we have you have the scanner app, then we have the authentication. A user need to authenticate itself before start using the scanner. We have two methods, primary authentication and secondary authentication. So in the primary, we will be using the username and password, and for the secondary, we will use the location-based authentication and keystroke-based authentication that will use the behavior and movement of the user to authenticate the user for that scanner. Then of course we will use the context management. Okay, so this is an example of the app FC Scanner. You can see this runs in a mobile device and it could be used to scan the smart tags. So the scanners are developed as a mobile application and it will scan the smart tags. The basic features are it should be able to do the user authentication. So unauthorized user should not be able to use the FC scanners, and it should be able to decode the data matrix and NFC code, because these are the techniques we are using to create the smart tags. And then it should be able to collect and send the requested context information. So along with the information that is extracted from the smart tags, the scanner should also be able to collect and send the requested context information. Now, the requested context information varies with the application. Like it would be different for milk, it would be different for home services, it would be different for meat. So it could be different depending upon the application that is using the smart tags and the scanner. So the information view would be like this, that we have the smart tag creation and printing, then we have the scanner to scan these smart tags, then we have the information that should be pushed from the front end, that is the scanner and the tags, to the back end where we have the Tagged Smart platform that will collect the information, process it, and that processed information could be used by the service providers to provide additional information. Then we have push information to users also in terms of new services or in terms of the details or the story of the product that the user is scanning. And these are the 5 use cases that we are considering in this project. We have digital beer, we have the recycling. So as I said that we are not tracking the product until it is bought by some customer. We also want to track it after it is bought by a customer. We want it to track until it is put in the recycle bin. So in this way, we can you can say that we want to promote the recycling also. Then we have brand protection, because it is important for at least for the good brands. Then we have dynamic pricing, and then we have home services. So these are the 5 use cases that we are considering in this project. Or you can say that for these use cases, we will be having the field trials that will use the smart tags and their functionality, and we'll see how it will go in these use cases. And these are some templates for the use cases that we are using. So we have life cycle management, we have digital product, we have tagged wine. This is for the wine only, and then we have home services. And then we are also involving the users during the project using the Ovela platform, and it is a platform created by the VTT. through which the users can give their feedback on the ongoing activities of the project, and they could ask questions. They could actually give their feedback on the tasks that we are reporting in this. It's like a form where you can go, you can check what is going on going in the project, and then they can provide their feedback, or they can ask for something particular related to the text that is written there. Thank you. So this is the project I'm working, and so it's an ongoing project. It still has more than 1 year to complete. Thank you.
Questions?
Thanks.
Okay. So first of all, thanks for the invitation. So
It might be good if you want to stand up because you're not in the
oops.
exactly stability. You might have a problem with your mic.
Is it fine like this? Okay. Okay, so this is going to be a web security talk. In general, web security is a pretty complicated topic for a number of reasons. One of the main reasons is the complexity of the threat model. Besides the traditional network attacks, which you all know, I guess, where basically everything which is sent in plane over the network can be inspected and corrupted by the attacker. We also have web attacks, that is malicious website or content injection vulnerabilities. There are a number of attacks against a website. Here are some names. You may have heard about it. It's not so relevant right now, but just to give you the background, the context. Various session hijacking, various cross-site purpose forgery, SSL strippings. And so in particular, it is very natural to put some security enforcement inside the web browser, because everything is so complicated that you don't want to really rely on developers. You just want to enforce everything in the browser the best that you can. The problem is that even if this idea is very appealing, the same origin policy, which is the baseline defense mechanism in browser, is pretty weak overall, because it can be easily circumvented by the so-called content injection attacks. For any of you who are not aware of content injection, which is typically called XSS in the context of web security, the idea essentially is that you have some input which is manipulated by the attacker. So it is a low integrity input which gets picked by a web application and put inside a trusted context. So there is a simple example here where basically you have a search engine implemented in PHP. It's a very simple example. Think about, I don't know, some website which has a session like Google. So you have your own account, you're logged into the website. So what the web server does is it will start a session so that it identifies you, and then it will wait for some query from you bound to the parameter queue. It will perform a query on the database, and it will print the result for you in your browser, okay? And what it will do is, assume you submit some search term, say banana, and then it will write the result for banana with the underlying tags. So what happens in this case is that this page is getting something from the external environment, potentially the attacker, and plugging it inside the web page, okay? So if this thing is not a search term, but is a maliciously crafted input, what happens is that the maliciously crafted input gets embedded into the web page, and it will run as a script submitted by the search engine. So in that specific case, assume the search engine is hosted at wiki.com. What the attacker can do, it can craft a link, where rather than submitting a search term to the search engine, it will provide something which closes the underlying tag and then puts a script inside the page. And this script, for instance, can read your cookie, which identifies you to Google, say, and send this cookie to the attacker website. So this is called a content injection attack because there is some content which is supplied by the attacker which gets injected inside a high security website. And since this content cannot be distinguished by legitimate content which is on the website page, what happens is that the same origin policy, which prevents different websites from accessing each other cookies, will not work in this case. And this problem is so widespread on the web that the W3C proposed a mechanism which is called content security policy, which is designed exactly to prevent these attacks. And the idea of content security policy is that you have a language where you define some restriction on content loading, and you have this policy specified at the server side, and the policies are then enforced at the browser side. And the core strategy to prevent XSS, traditionally using CSP, is that CSP by default prevents the execution of inline script. The idea essentially is that in any page you can have either inline scripts, which are embedded directly into the page, or external scripts which get loaded from remote origins. And so, since injection in the end tries to put something in among the embedded scripts, what you do is you prevent inline script by default. And as to external script, what you do is you constrain the set of web origins from where you can load this script using a whitelisting mechanism. So if you apply this practice, what you do is you prevent evil.com from giving you some script which gets injected into trusted.com. At the same time, you say that evil.com is not a valid source for script inclusion. So concretely, this is an example of a content security policy. It's very simple, as you can see. What the policy says here is that the web page can only load scripts from example.com using HTTPS. And implicitly, this is also saying that inline scripts are forbidden. If you want to relax this restriction, you can add unsafe inline here in the list, and you will get this restriction unlocked. But this is, of course, not recommended from a point of view of security. And also what the policy says is that you can load images from every place on the web using either HTTP or HTTPS as you like, from any website, but you cannot load anything else. So you cannot, for instance, load style sheet in this page. This is going to be prevented by your browser. So CSP is great, it's a very nice idea, but previous research found a number of issues in the current CSP deployment. In particular, it is known that many websites use unsafe inline for backward compatibility reasons, because the real websites use inline scripts, and so since to use CSP you have to move these scripts to external files, many websites just don't do it and use unsafe inline, which is insecure, of course. Writing whitelist for script inclusion is difficult. They are typically too strict or too large. We also published a paper about this at CCS, and there is also another interesting paper at the same conference by some Google guys, where basically they show that it is so easy to come up with whitelists which are too permissive. And another issue in general is that static whitelists are often difficult to write because many contents are unpredictable. So, for instance, assume you load advertisement, you don't know what's going to happen, or assume that something gets relocated to some other place you don't know, you can include this origin inside your static whitelist. This is something you cannot do in general with this. And CSP evolved during the years. In particular, we now have some very good techniques to solve this first problem. You now have ways to whitelist scripts very precisely, even if the scripts are in line. So you can use, for instance, hashes of the script to denote, I will run any script provided that it matches this given hash. But these other two problems are often overlooked. So there is no robust research on how to deal with these features. And this is exactly what we try to do by proposing CCSP, or compositional CSP, which is an extension, a conservative extension of CSP, which is based on a mechanism which we call runtime policy composition. And the idea essentially is that page developer only specify a very simple policy which is initially enforced, and this policy can be relaxed by content providers, because there might be some dynamic components which are not obvious to you, the developer of the page, but they're totally clear to the provider of the content you load, like say the advertisement networks. And so we start from a simple policy, we relax this policy by interacting with the content providers, But at the same time, we don't give full control to these content providers because we can still specify some upper bound on the allowed policy relaxation mechanism. That's the core idea. This is an example which I used to tell you the cool points of CCSP. So assume you have some page at p.com, and this page loads some JavaScript from a.com, and this JavaScript in turn loads some other stuff, in particular another script, a dependency from b.com, and an image from c.com. So this is already a pretty complicated scenario, even if I consider only a limited number of resources. And it is instructive to understand how CSP supports this pattern and what we propose to do instead, okay? So please try to keep this in mind. The idea of CSP traditionally, so the first two versions of CSP, is that everything which is loaded into my page must be included into the policy. So if you pick again this scenario, in this case I'm loading one script from a.com, one script from b.com, and one image from c.com. So what I do is that I whitelist everything explicitly in my policy. One script from A, one script from B, and one image from C. This is great, potentially, because you have full control on what the page is loading. So you know that only this thing can be loaded. There is no room for the attacker, right? But the problem is that this policy is hard to write down, because it means that you have to identify all the script dependencies into your own page. And moreover, this policy is brittle because it's complicated to maintain. If anything changes into your own page, you have to update the policy correspondingly. So if, for instance, one dependency gets relocated, I have also to update my policy to make it work. And since policies in this format are difficult to write, there is an evolution now, which is the new version of CSP, which is Csp Level 3, or colloquially known as strict CSP. And the idea essentially is that we are not using whitelist anymore, but we use nonces. So what you do essentially is that you pick the script into your own pages, and rather than whitelisting the origin, say a.com, what you do is you plug a nonce into the script tag, which is an unpredictable value. And what you do is that you refer to this script by plugging the value directly inside the policy. Okay? And what's the problem, of course? The problem is that whatever is loaded by this guy will lack potentially a valid nonce. Okay? And so what you do is you can use a directive which is called strict dynamic, which means that everything which is loaded by something with a valid nonce is also allowed to be loaded. So in this specific case, we simplify the policy specification because we don't need to whitelist a.com and b.com anymore. What we do is we just whitelist a script here using a nonce. And then everything which is loaded by this guy, so any dependence, will be accounted for by strict dynamic. Okay? So we're simplifying policies. If something gets relocated, we don't change the policy, which is good. At the same time, as you can see, we're only solving partially the problem because images are not covered by strict dynamic. So in this case, the dependency from c.com must be still made explicit inside the policy. So yeah, we're converging, we're improving, but we're not defining a real solution, general solution to the problem. So indeed, the good point of this is that we're improving protection against script injection. We're not whitelisting the entire a.com anymore, but we're just whitelisting one specific script with a valid nonce. We're improving robustness to code changes in script because we use strict dynamic, which does all the magic. But at the same time, as anticipated, we have a limited scope, which is only limited to script specifically. I cannot support, for instance, with the same tree, the load of image. There is a very poor granularity, because if I put script dynamic into the policy, everything which has a valid nonce can open up my policy to load other stuff. But not all these guys need to request this capability. Some may need it, some other not. But with strict dynamic, I just give this capability to any script in the page. And the last point is that there are some bypasses on nonces, but besides this, let's say, hacking trick, nonces in general complicate security auditing. Because if you have a look at this policy again, when I look at this policy, I don't check the page content and see this nonce here. I don't know what I'm including, right? So I'm losing some information in the policy, which makes the security auditing more complicated. So what we propose is to instead to use a new mechanism, which is CCSP, where essentially what I do is that if I am a developer of p.com, I will just write a simple policy for P where I only whitelist the direct dependency of my page. In this case, what I will include in my policy is just that I'm loading something from a.com. And this is supposed to be easy to do because the direct dependencies are limited in number. And what happens next is that everything which I include can provide a new policy which accounts for all the indirect dependencies from this guy. So in this case, the policy from a.com will mention that something needs to be loaded from B and some image must be loaded from C. That's the core idea. At the same time, I'm not giving full capabilities to this guy, but I'm specifying some relaxation bounds by saying that some policy relaxation are not allowed by me, so this should not be performed in the browser. So concretely, this is implemented as this. When I write a policy for p.com, I have two parts in my policy. One part which is called Csp compose, which tells you the initial policy, and one part which is called Csp intersect, which instead intuitively is the upper bound. So what happens is that in this case, in the initial policy, I only whitelist stats.js, which is a script from a.com, and nothing else. And what I'm saying here with this policy is that if I get some script from a.com which is called stats.js, this script can open up my policy a little bit, and in particular, capabilities which may be requested is loading any script from the web, provided that this script is loading using HTTPS to provide integrity to the script. The script can open up my policy to load images from any place on the web, whatever it likes, but nothing more. So this script, for instance, cannot request the capability to load style sheet in this case. And what the script provider will do, will provide me a new policy in the CSP union header, where essentially all the script dependencies are whitelisted. So in this case, there is a script dependency from b.com, which is called that.js, and there is a dependency from c.com to load images. Okay? So that's the core idea. What the browser does is it starts by enforcing this policy, and when I interact with this guy, it will open up my policy, provided that this relaxation is allowed by the upper bound. So concretely, at runtime, when I interact with a.com, what I will do is that I will notice that there is a dependency from B, and this is fine because this is loaded over HTTPS, and this is consistent with the upper bound. There is the request to load images from c.com, and again this is fine because this is consistent with the upper bound. So what the browser will enforce at runtime is this policy, which is, as you can see, this is a very expressive mechanism. So I start with something simple and will open up the room to more behaviors. What are the benefits and the drawbacks? So the benefit is that in the end we have a realistic support for fine-grained whitelist. Since I only whitelist direct dependencies, I can be very, very precise because they're relatively easy to identify. Moreover, I have a mechanism which is very general. It really solves the problem. It's not like strict dynamic, which is only essentially a patch to make it work. And moreover, I can specify different upper bounds for different scripts. So I'm enforcing the principle of least privilege on policy relaxation. If some script does not need to relax my policy, this can be enforced. Of course, the main drawback of this is that I'm requiring some collaboration to content providers, because I write my initial policy and I expect the content provider to give me the policy with all the dependencies. So we need to give incentives to these content providers, first of all. But I think that this is reasonable to assume, because in general, if you think, for instance, about advertisement network, if I'm loading some advertisement from the network and my content security policy breaks the advertisement network is having an economic loss. So the advertisement network is interested in writing a policy which opens up my content security policy to support the advertisement. Okay? Another issue is the complexity, which of course we are adding expressiveness, and since we are more expressive, we are also making the system more complicated to debug. But this is something which is found acceptable in practice. I'm not going to discuss all the design in detail, that's the core intuition. If you're interested, you can check the paper, where essentially we have a security analysis, a backward compatibility analysis. So we show that if you introduce this thing into the browser, you're not going to break legacy websites, essentially. And we have an analysis of the deployment cost, which we show basically it's very easy to deploy because you can implement CCSP on top of CSP as a black box. And indeed, we have an implementation of this. And it's nice because we use the Google Chrome extension API to develop an extension. And the extension using CSP as a black box, so the implementation of the extension is very, very simple. If we have to implement these things in browser, will be a very limited code size change. Very briefly, because I don't know how much time I have, but I want to show you some of the benefits of this. So what we do in the paper also is evaluating the impact of this solution. And what we did essentially was crawling the top million websites of Alexa. We found all the websites which support CSP. And what we did essentially is that we instructed the browser to send all the CSP violations we found in the wild to a web server which we control. So we log all these violations. And in particular, we find violation in a pretty high number of websites because the number of websites which support CSP is limited. This is a very large fraction of websites. And what we do is that we identify two particular interesting classes of violation which we are interested to check. One are dependencies, which, as I told you, is difficult to support because they're difficult to identify. And the other one are redirects. Because if something gets relocated, you have to update your policy to make it work correctly. So also this is something which is hard to fix in CSP. And so, as to script dependencies in particular, we observe that script dynamic is a very nice thing because it allows you to fix, by using it, 96 violations. But we also have a bunch of violations, which is around the 60%, which are not related to script dependencies. So for these cases, all the other rows in this table, script dynamics does nothing. Okay? So you really have to adapt your policy. If you add a mechanism like CCSP, all these cases are uniformly supported. As to HTTP redirect, there is nothing in CSP level 3 which supports this pattern. So for all these cases, you have to adapt your policy by hand, manually, which makes deployment more complicated. And again, this is something we support in CCSP. As anticipated, we implemented CCSP as a Chrome extension. We also we performed some testing in the wild. We found CSP violation of major websites like twitter.com and orange.sk, and we fixed this violation by using CCSP. And we also tried to quantify the deployment cost of CCSP for the most popular script providers. And you can see from this table, the number of scripts which are used in the wild is fairly limited. So essentially, each row in a table is one provider, and here you know the number of scripts which are loaded from this provider. So, for instance, this provider would only need to write 3 policies to make everything work correctly in CCSP. And the number of policies and the complexity of the policy is limited because you can only find a very small number of violations in the wild. So we find only 5 different violations. So, if the interesting point is that if we deploy CCSP on these providers, which are 9, we're essentially covering the large majority of the web. So if we only patch, say, Facebook, Google, Twitter, etc., what we end up having is that we have a more secure web with quite a limited effort. So we delegate effort, and we provide security to a much higher number of websites. This is a summary slide. This is the original proposal of CSP, level 1. There is the new industry standard CSP level 2, where basically we have the possibility of whitelisting individual inline scripts so you are not forced anymore to move all the individual inline scripts to external files. You have a controlled way to whitelist them. We then have CSP level 3, where essentially we have a simplified process for recursive script inclusion. So you have a way to support script dependencies much more easily. And we are also improving the policy specification because policies are way less brittle if you use this technique. And our proposal instead gives another new layer of expressiveness because we introduce a new general mechanism to relax policies at runtime, still based on whitelist. So we recover also the possibility of simplifying the security auditing because everything is embedded inside the policy. So to conclude, there is a real-world research which shows that CSP is facing deployment challenges in the wild. CSP is evolving to deal with these issues, but CCSP is the first extension of the standard which supports the dynamic nature of common web content like advertisement and Csp Level. We designed it to make it secure, backward compatible, easy to deploy. You can check the paper if you're interested for more details about this. Of course, this calls for a paradigm change with respect to traditional CSP because now we have collaboration. It's not everything in charge on the page developer. And you may like it or not, but what I would like to stress is that our proposal is an academic proposal. So it has some, let's say, price to pay in terms of deployment. So we don't know whether this is going to be implemented in browsers in the end. But if you like it or not, what I would like to stress is that all the problems we identified in the paper are problems which are real for CSP. So we're blocking deployment as of now, and if we don't see implementing the browser something which deals with advertisement and Csp locations, we suspect that CSP is going to be very, very hard to deploy overall. So this requires a robust solution. Thanks for your attention. If you're interested in CSP and if you want to have a look, we have a web page and you can write us to this email address.
You mentioned Twitter and another website.
Orange.
They violate these policies?
Yeah, basically, one problem, we have two problems in this website. Orange is the most interesting one. So for Twitter, it's basically an omission. So Twitter was loading something, depending on a value in the DOM, and this probably was not noticed by the developers of Twitter. So one legitimate functionality of Twitter was broken by CSP. And you can notice it because when you access twitter.com in the browser, if you have a look at the console, the JavaScript console, you will find violation logged there. In our case, we logged them automatically using, the idea is that we inject headers into the page so that all the violation gets redirected to our own web server. This is a much more interesting case, the orange.escape, because when we looked for violation on this website, we found a violation because this guy was requesting something from google.it. And what we observed is that based on the language of your browser, this is going to request stuff from Google at a different top-level domain. So if the browser is in Italian, it's going to request something to google.it. But if the browser is Slovakian, it's going to ask for something at google.sk. And indeed, we observed that this guy is whitelisting google.sk, but is not whitelisting any other domain of Google. Because possibly this guy was only tested using Slovakian browsers. Instead, if you use CCSP, what you do is that when you try to contact Google, you give Google the capability of relaxing the policy to support the correct top-level domain. So you can fix violation very easily. And this is indeed one interesting case where you really want to use CCSP.
And you notified them?
What we did basically is we have an extension which enforces CCSP policies. And we injected headers on the response from this guy, so that rather than providing standard CSP headers, we provide CCSP headers. And by writing this policy, we were able to show that the websites work correctly. We are not stopping anything from working.
Other questions? Once again. Maybe you can take a 5-minute break and then
Not online.
Slide on.
Google, you can.
It's public available.
No,
But
it's
really
No, what are you doing? You can stop.
No.
But you can find it on the website. But if you write me an email,
No, I think it's reduced size, not 1 million.
yeah, send me the problem is the list I have is a bit outdated. Because when we did this,
You're still talking, so you should say something valid or... Okay, sorry.
I can start with a bit outdated. So what is the information? I will send you my updated list, and also if you want to, I will send you the instructions to get the most updated.
What the fuck? Who stopped it?
I didn't touch it.
What the fuck?
I don't know. You did it. Just warn me.
Use this to put because it's scripted.
Are you sure you cannot increase the resolution? Okay. So why YouTube doesn't want it? Why you have in Italian?
Because it's SPRITZ account.
Seriously?
Yeah, this is SPRITZ account.
Let's try normal latency.
No,
Who cares? Even if it's
you have to stop to do anything. Okay? If you stop, the link will be regenerated. Then I have to post to all social media again. Website.
okay. I think that you can modify that without stopping. No. Okay. Stop.
That's it. Now the same, but a bit down. Are you sure? This way? Before you can also
But she said
Pardon? Just 2 minutes, it's warming up. No, it's okay.
Okay, you can start again. So next talk, we learn what the machine can learn in this video.
So, good evening one and all. So, my topic of presentation is, can machine learning be secure? It's a generic topic. We start with the basic fundamentals of machine learning, where we understand what machine learning is and what feature is, what feature selection method is. Then we go for the adversarial machine learning. We see the basic attack models that are proposed, and I would talk in perspective of malware detection. So the famous definition from machine learning is, it is actually, we are interested in building a computer-based system which can adapt and learn by experience. But how this learning can happen is, the learning can happen either by self-study, or it could be by some experience, or it could be a machine that is being taught. So formally, if we say that we are interested in building a computer-based system which learns from an experience E to perform a task T to achieve a performance matrix called as P, and always the primary motive is to improve the performance based upon the experience. The important thing over here to understand is, if we are trying to construct a machine learning model and to improve the performance, the input that is given to the model should be variable, otherwise the machine learning model will be biased. So these are few examples that came to the mind, like given a 20-year of clinical data, is it possible, like can we predict that in the next 5 years the patient will suffer from heart attack or not? Or we have the price for a stock, can we predict the rate of the stock or the stock market rate after 6 months? Or it could be like, if a handwritten number is 7, can the machine learning model recognize it properly? Or the email that is received by my mailing system, is it spam or a ham? Or we can cluster the people based on we can cluster the people, the customers, or we could cluster the words, or we could cluster certain genes. So ideally, if we try to classify any machine learning model, we have 2 types of model. One is called as a supervised learning, wherein the basic premise is each element or each input vector that is supplied to the machine to a classification system is labeled. So for such a model to work properly, it's very important that the input, vast amount of input to be collected from wide and from the known repository, so that the model gains more experience. It is also called as predictive data mining techniques, wherein the classifier model try to induce theories from the algorithms. So this is a generic model of a supervised learning, wherein we have a training data set which is labeled, and these are the input feature vectors, and we give the unknown samples, and the model will try to identify these samples belonging to the category yes or no. So the next technique is called as an unsupervised learning method, and in this model the label corresponding to an input is unknown. So the primary techniques that we use is called as clustering. We can go for linear or hierarchical clustering. This is also called as descriptive data mining techniques, and the groups or the clusters are basically formed by learning the statistical distribution of the data. So the important thing in any clustering algorithm is that the interclass separability distance between a cluster is tried to be minimized, but the interclass distance is maximized. So what I am saying is, within the class the distance of point should be minimized, and across the class it should be more. So this is a generic model of any classification theory. We start with the historical data. We perform certain random sampling. Over here in the pictorial representation, we show that the data set is divided into 2, like 60% of data is used for training, the remaining is reserved for testing. With the training data set, we extract the features, we do feature processing, and then we try to build a statistical model. And the testing data set, from which we never extract feature, it is given to the prediction module, and the performance is actually appraised. Also, we can have a new data set which comes after the training data set, and we try to evaluate the performance of the classification model. We have another technique which is well-known theory, which is called as cross-validation. Just for the explanation, I am just showing this diagram wherein we show that the data set is equally partitioned into 4 halves, and with 3 subset the model is trained, and with one of the subset it is tested. This is repeated 4 times, and the average of the performance metrics is used to evaluate the performance of the classification technique. And these are the plain matrices that we see in almost all papers, that true positive, false positive, true negative, and false negative. Other than that, we have many other metrics like FN measure, precision, receiver operating characteristics, Matthews correlation coefficient. Okay, so these are just the basic things. Now we come on to an important concept called as a feature. A feature is nothing but it is an attribute corresponding to an object. It could be quantifiable, or it could not be quantifiable. Now, when I say it is not quantifiable, from this picture I am talking about there are two flowers, and I want to classify these two flowers. What is the feature that can be used for classification? So if it is a rose, I say that if the color of the flower is red, I will say it's a rose, and if the color of flower is actually white, I will say it's lotus. If a classification model is built using one category of a feature and it is subjected to new samples, something like this, where I now give apple as an input, which is my test sample, and polar bear as another input, the classification model will try to misclassify the instance, treating apple as a rose and polar bear as a lotus. So what is the basic understanding from this is a feature engineering is a very serious and a critical issue in machine learning paradigm, wherein a single feature may not scale for building a robust classification model. A sample or a feature is called as a feature vector, and the total number of attributes with which a sample is represented is called as a dimensionality. Higher the dimensionality, there will be more noise, so there has to be some way of reducing dimension and to preserve important part. And what should be the motive in constructing a model is the feature vector across two classes should be highly separable, but within the class the feature vector should have minimum variability. So what is the definition, or what do we mean by useful feature? Now there are primarily three important concepts of usefulness of feature. One is like a feature that is present in fewer instances of the target class is not relevant for classification, so it should not be considered. There has to be certain mechanism or certain algorithms which should try to prune such features away. Second one, a feature that appear with the nearly similar frequency in the target classes cannot be called as useful, so they are categorized again as insignificant, so they should be also removed. Finally, a feature that is present in majority of the instances with maximum weight of frequency in one class, but it is present in other class in a lesser frequency, or they occur in fewer instances, might be considered as important. So how can we extract important features? There are certain techniques called as feature selection technique. This is just a broad picture. So the feature selection approach basically tries to eliminate irrelevant and redundant features. So the benefit of feature selection technique, or the robustness of a feature selection technique, should be the lower dimensional feature space should actually try to represent a input vector in the same qualitative manner when the higher dimensional feature was present. Also, if we have a lower dimensional feature space, it would be very easy for an analyst to visualize it, or data visualization is good. So we are ultimately eliminating noise or outlier. It might improve classification accuracy and reduces time for the model generation. But the most important thing is mining or extracting the suboptimal feature space is an NP hard problem. So next we come on to another concept which is called as an adversarial machine learning. So adversarial machine learning is like a branch of machine learning techniques in which we are trying to understand how the adversary or how the opponent is going to behave. So our interest, or the defender's interest, is like how do we try to understand the capabilities of an opponent and what are the limitations of an attacker. So broadly, the adversarial attacks are categorized into two. One is called as a causative attack. In a causative attack, the attacker is trying to alter the training process through the influence of the training data. And in case of an exploratory attack, the attacker is trying to probe the detector by submitting some samples. So the summary is that the defender always have a wrong notion or an assumption that the training data and the test data, they both come from the same distribution, or the test data is not going to be changed, but somehow it is not that. There is a problem, something called as concept drift. So if we formally try to understand what an adversarial attack is, let's say that we have a given input X, which is consisting of a set of feature vector, and there is a classifier model F. The feature, the input vector X actually maps to a class. That is what I mean to say, every element will belong to some or the other class. So, and let us say that such a class is Y, and we start with the adversary will start with a seed sample, a starting sample called as an X, which is belonging to the set X. Now he will try to introduce some sort of a perturbation in the input sample, such that the norm of the existing samples in the data set, okay, it should be minimized. Also, the class of the new sample should be something that he desires. So that is called as a targeted attack. So what I mean over here is, like, if I have a malware sample, and if I want to bypass this sample through an online detector, let's say there are many online detectors for PDF malware called as PDF rate, and we have something called as origami, Vapavet. So what I will try to do is, I will take the PDF samples, I will try to reverse engineer the PDF sample and introduce something that is there in the benign instance and push it onto the classifier, so that the malware actually is identified as legitimate. Now in case of an untargeted attack, the attacker does not want his sample to be classified to a particular class. He doesn't have any target. He just wants either it should be a row, or it should belong to some other class, or it could occupy any of the class. So mathematically we represent it as function f of a should not be equals to f of x. So the adversary do not specify any class. So this is just a pictorial representation. So the basic assumption is minimal. The adversary should try to induce minimal disturbance in the sample, so that the sample is classified as legitimate. But a powerful adversary will somehow have a knowledge of the trained classification model as well as the input data. But this is just an assumption, but it may not work in realistic terms. So we have many applications wherein the adversarial problems have been identified. Largely it has been implemented in computer vision. So this is one of the mechanism. For the human eye, we see that this image is a panda image. We apply a disturbance to this image. I am superimposing a noise on this image through certain mechanism, and when this is given as an input to the classifier will try to understand this image as gibbon, but the human naked eye still believes that it is actually a panda, but the classification system will not try to understand it. Now similar approaches, like in pattern recognition, on the top it is the images of certain digits as well as the signs, which is shown in the second row. We are perturbing this image by introducing certain noise, which causes the image to be represented like this, and the classifier is misclassifying the instance, like 0 is classified as 5 and 3 is classified as 8. Still the human understands that it is actually the same number. So the problem is, like, if we have a driver-less car, and if I put a sticker which is actually changed by me, it can create lot of problems. So such adversarial problems on the physical world also have been dealt with. Now, the third application where adversarial learning has been implemented is spam filtering. So we collect the historical spam data or a label data which is represented as a vector like this, and we assume that there is a classification, a linear classification, where one cluster is actually a ham or another cluster is spam, where the positive one is called as malicious and the negative one is called as the legitimate. And let us, for our assumption, take into consideration that the model is built by the bag of words. So this is the representation where it says that start is occurring only once, so we are writing the presence or absence of a particular word, and correspondingly through certain mechanism we also have associated a weight with it. So if you don't have any particular word, we give it as a negative word, negative weight. So during the test, what happens is the weight is actually multiplied by the presence or absence of a sample, and a score is computed. And we say that if the score is greater than something, the instances are called as spam, and if it is less than something, the instance is classified as ham. Now, after this, now what adversary will do is, now he will take certain samples, certain historical samples available in the repository. What he will try to do is he will try to change certain words and introduce a noise. So our classification model only understands a specific type of a feature. Now this is now turned into 0, but he will introduce something else. So ultimately, when the weight is calculated, this instance is now identified as ham. So merely by misspelling of word, the class is actually changed. So we are changing the direction of a sample. Now we have few formal notations to look on because we have to understand how adversarial samples are created. So for your consideration, I just summarize it by putting a table where X is an input sample and Y is the class associated with X. Theta is the model parameter, J is any cost function corresponding to any of the classifier, where theta is the classification parameter, X is an input, Y is the class. X star is a new instance the adversary is going to create by perturbing this X by introducing a small perturbation epsilon, and clip is a function which tries to see that the new instance is actually lying very close to the existing population. So the simplest thing what we understand is if we want some bad thing to be classified as good, what we do is we learn the feature, we see the average distribution or standard deviation, and we change the value of the input correspondingly. So there are various ways in which we can create an adversarial sample, and one of the mechanism is called as a fast gradient sign method. So whenever a classification model tries to work, it during its subsequent iteration, it tries to see that the cost function, the loss is actually minimized. Okay. So what we try to do, what is done in fast gradient is like the adversary tries to prepare a new sample X star from X by introducing a small perturbation, something like this. So this is a sine function, and this is the derivative of the cost function. And another method is called as a basic iterative method. In the basic iterative method, what we do is we take the samples from the previous iteration and we apply the perturbation on the sample, and then we get a new sample. We run it n number of times, Also, we try to evaluate at each iteration that the deviation of the new sample is not extraneous, otherwise it could be easily caught by the defender. So, and there are expensive mechanisms like genetic algorithms, which was addressed in one of the articles to generate evasive PDF samples. So in this, the data set, the population is initialized. For every sample, the fitness is calculated. It is then done with crossover and mutation, and after every samples are generated, we see whether it is having enough strength to go for the subsequent rounds using the survivor selection method, and those samples which will be useful are actually given to the classifier, and then it is seen whether it is evasive or not. So I feel now these are this picture is actually the basis of any adversary attack. Now we go to the left side. So here there is an attacker, and an attacker always has an access to an oracle. For example, if I talk about a malware detector, my oracle will be a sandbox like Cuckoo, or my oracle will be an online scanner like PDF-Rate, or my oracle will be an online scanner like VirusTotal. So what an attacker is doing here, somehow we assume that the attacker has a knowledge of the classification algorithm with which the oracle is constructed. So the attacker will try to probe certain inputs to the oracle and try to get the result, whether it is legitimate or whether it is malicious. Now at the same time, what he will do is he will try to prepare a surrogate classifier. Now by surrogate classifier, what do I mean is he just have a knowledge of what type of classifier he is using, what the oracle is using, and the attacker will somehow try to collect samples from different sources and make changes and wait until the substitute will give a wrong answer for a malicious instance. Okay. Then the second thing is, when this concept is known to him, he will try to apply the transferability issue. Now what is transferability issue? Over here, the attacker will now try to create a substitute with a different type of an algorithm. Like he is trying to see how neural network is going to work along with the decision tree. He applies the same perturbation and he waits until a sample is misclassified as legitimate. So if he is able to do this properly, so for any classification system, okay, which works on a victim, surely he can thwart this particular detector. So it can be compromised. So basically what has to be done here, we have to see different pairs of classification algorithm, and we have to analyze the performance based on certain input. But this actually is a time intensive task. Now this is a generic model of adversarial malware detector. So where we see that this is in terms of PDF. So we have a large collection of malicious PDF. We can collect it from sources like Contagio Mobile Dump or benign sample. We randomly mix it and we find out, we try to create a population. We have to compromise a victim. So using the oracle and the target together, the adversary tries to compute a fitness function. If the sample is evasive, then he will check whether the sample is evasive. If it is evasive, he has found out an evasive sample. If it is not evasive, what he will do is he will try to check whether he has reached the maximum generation. If maximum generation is not reached, then he will select a new sample. He will apply certain mutation operators. Now, what could be a mutation operator? A mutation operator could be either insertion of a feature or it could be a deletion of a feature. But it has been investigated thoroughly that the deletion of the feature will lose the maliciousness, original maliciousness of the sample that is subjected to it. So what they do is they try to add features into the feature space instead of deleting it. Now there are many attacks. So this is one of the attack which is called as a mimicry attack. There is another form of an attack which is called as a reverse mimicry attack. In mimicry attack, what the attacker does is he tries to create a surrogate data set of malware and benign. He tries to extract the features, and based on his data analytics experience, he will try to generate important feature or a discriminating feature. Next, what he will do is he will take the benign data set, he will learn the distribution in the benign data set, he will try to add some perturbation on the discriminative features, and he will check whether the perturbation induced on the sample has made the sample legitimate. If it is legitimate, he is successful, his total work is over. If it is malignant, what he will try to do is again he will try to see the distribution of the discriminant features. He will check again with the model. Again, if it is classified as malware, what he will do is he will add more discriminant features into the feature space. This process is repeated until and unless a malignant sample goes evasive. So, like, what are the defense mechanisms? Yesterday we heard one defense mechanism, and this is very prominent in machine learning, which is called as an ensemble learning. So this is a simple diagram of an ensemble learning. You have a training set, we have multiple classifier, and finally the decision is based on certain criteria that we will be seeing now. So the ensemble learning performs well even if the members are poor, and they perform well when we have diverse classifiers and each classifier is actually subjected to diverse features. So we have various mechanisms for creating an ensemble. One we saw yesterday, which is called as majority voting. Now these are the class labels. Now here you can see there are 2 zeros, so we will say that the sample X will be classified as to fall into class 0. Then we have a weighted majority matrix method where every classifier is weighted based on the previous history. So let us assume that these are the weights. So you multiply the weight with the label, and whatever is the result will be actually the identifier for the class. And finally we have a soft voting mechanism, and which considers the probability as well as the weight. So we say that this is a class 0, this is a class 1, and the classifier identifies X with this probability, and finally we use the conditional probability, and over here we see that there are two values. Finally it says that 0.51 is greater than 0.49, and a sample is classified to a particular class. Then lastly there is another defense mechanism called as mutual agreement. In mutual agreement, our interest is, like, we have two classifiers and we give an input of a sample. We check whether both the classifier agree to classify an instance to a same class. So this is done across multiple instances. So this is called as a mutual agreement, and this is an output function. The predictor over here checks whether the class labels are similar. If it is similar, then the classifier is actually classifying things properly. If the mutual agreement score is less, then what we try to do is we try to identify all those classifiers which are falsely classified instances and we retrain it. Or the second methodology is we try to see the pattern of the classifiers which are weak across all subset, and whichever classifier is coming maximally in all subset, we try to retrain them. Having said this, the defense mechanism is like if we want to create a robust classification system, we should train the machine learning model with the samples that can actually bypass. So here the defender will anticipate the samples which can be perturbated, so with which we will actually train it. So but whenever we are modifying, we should see that the functionality of the sample is not lost, it's not a rogue sample. And how do we try to save our system? The defender should not generate any score corresponding to the sample that is pushed into the system. It should be either a boolean yes or no, or it could be some random weight, or the scores could be collected from multiple classifiers. So but if it is so, it would be very difficult for an attacker to actually guess the score. Instead of simple superficial statistical feature, the defender should always create his model using semantic feature, because semantic features are basically very difficult to guess. Then we try to identify a set of features that are susceptible to be transformed by the adversary. So those features which are having higher variance towards the target class will be the first target by the adversary. Also few solutions could be to find out the features which are having high correlation or related. So if there are 3 features, if I remove one, then again the dependency is broken, then the detection, the detector will be good. And the classification algorithm should be modeled by collection of large samples from a large repository, and definitely it should capture the input vector where the deviations are from the samples of the legitimate classes. These are some extra slides wherein there is one paper by one of the researcher by using the static features of an Android file to classify whether it is evasive, legitimate or malware. And if we have an email, these are certain statistical features that can be used to classify, and they have been reported in case of an adversarial attack. I close my presentation. I will be happy to address to your queries. Thank you.
Thank you very much for the presentation. I just want to have questions. Questions coming from one of my friends in Florida, and it's so important to know more about the, let's call it, you say that you apply genetic solution. You discuss about some specific case adaptation situation applied in adversarial machine learning, as far as I know. And I just want to know more about the complexity of this solution. Did you consider a specific type of, let's call it, the general genetic algorithm you applied to your solution, or you use modified genetic? And maybe you can explain more about, maybe test about the complexity case.
Yeah, let me come to, this is, as I started my talk, it's a generic talk on adversarial learning. This is nothing of my work.
Okay.
So I am telling you the state of art of how the adversarial examples are generated. We definitely know that genetic or any evolutionary algorithm is time intensive. So the problem with the evolutionary algorithm is like it created multiple population, and the challenge for the defender was not only to identify evasive sample, he had to identify those samples which lost maliciousness. So it's a big challenge and it has been debated. So it is not what I did. I'm throwing away the landscape of what is there in adversarial machine learning in perspective of malware detection.
Okay. Let's back to your work. I would like to know more about, did you consider any complexity inside your solution? Did you test it for a large scale, or you just test it in a simple scale, or something like this? Just in case I want to know, just this.
I have not tested it.
Okay. Thank you.
Other questions?
Yeah, I have one. So I'm not an expert of machine learning, but I work with some guy here who is an expert of machine learning. So I recall that the discussion with him, we have different classifiers in general. And one issue is the interpretability of the results. So we have some classifiers like decision trees, which are very easy to understand what's going on, basically, and other classifiers like neural networks, which are very complicated to understand what they do. So it's a big mess. So I was wondering whether you told that the adversary can try to infer what the classifier is doing by trying to feed the input to the classifier. I was wondering if a classifier which are easy to interpret as decision trees should not be used in this context exactly because they're much easier to reverse engineer. Do you have any clue about this?
There has been an study for transferability, which we say that we have a classifier, we give some input to it and we learn some output, and then we try to change the classifier and we see whether the behavior is similar. But it could be only possible if the classifier is outputting the class along with the score of a particular sample. Like in case of the study that I showed, there is a tool called as PDF rate. When you input certain data to it, so it says that if the range of an instance is between x1 to something, it will be malicious, otherwise it will be legitimate. And then the attacker try to create a substitute classifier, okay, and he tries to reprogram and generate certain score of it, but there cannot be an equal correlation between two different classifiers. That cannot be easily made. It's very difficult. Thank you.
Yes. Good afternoon, everybody. So, this one actually I would like to explain, let's call it as a fourth presenter in this workshop. First of all, I would like to thank Professor Conti for his invitation, and thank for all of you for attending in this workshop. Well, I just want to highlight that I would like to explain about 4 papers, and due to the time which I have, I try to abstract to discuss of these papers. 3 of these papers coming from the IEEE transaction papers which we published this year, and 1 is the conference. So I just want to explain that I would like to talk about 3 problems. The first problem, as you can see the name, the lifetime aware commodity hardware machine states. I would like to talk more about the commodity hardware, one of the emerging hardware in the recent network environment. And I would like to discuss about the different states and the side effects of the different changing of the state of this commodity hardware, how it could affect on the lifetime of the network. And which criteria or which metrics we can consider in this network to decrease this problem. The second problem we would like to go toward for the joint solution of inside a cloud data center. We would like to take care and take into account also this transition change, and we would like to take care about two problems altogether. The first one is talking about a maintenance cost, the cost which caused by a failure rate over the devices inside this system. And after that, we would like to address the electricity consumption over this cloud data center environment. After that, which is coming from our most recent work, which is that's why it's not under review in transactional network and system management, service management. We would like to talk about a fault-aware service function chaining inside a software-defined networking. After that, we make a conclusion and I give some future direction. And at the end, I would like to ask you a question about your help, let's call it, your suggestions to me to improve my work. So for the first problem, I should say, so I just want to say that a different problem, I give a general scope of the problem and then explain about the results and the solution that we propose in it. With our problem, let's call it our work in all these slides, talk about the green networking. So you know that the green networking is the aim of the exploiting the power, using different power management policies inside the network in order to decrease the energy and electricity consumption of the engaged component inside a network. One of the most important components inside the network is commodity hardware. So what is a commodity hardware? Commodity hardware is the hardware that it used inside the system based on in order to manage the traffic. For example, if we have a huge amount of the traffic in the system, we need to turn on some devices in order to facilitate the process and speed up the task, and in order to respect the quality of the service of the network and avoiding violation of the service level agreement that we have with the users that they request these tasks. Commodity hardware, so as you know, the hardware that's sometimes added into the network in order to facilitate the situation of the network. Commodity hardware use different states. It could be in active mode and it could be in sleep mode. It means like a hibernate in order to use it in the later time by the huge of the traffic coming to the system. This kind of state efficiently manage the power state of the system. So if we use the different transitions over a commodity hardware, it's obvious that we could control the energy consumption and we go toward for providing a green networking. But we should address the big problem and the big issue that recently a lot of network providers are engaging with this type of commodity hardware. The long run or long transition of the commodity hardware, it has some side effect in the network. For example, if we consider the commodity hardware as a server, if we turn on-off server in a long period of time, we lose that kind of server because the server's lifetime have been passed. So the content provider and the cloud data center providers, or the, to be generalized, for the commodity hardware providers, it's so important for them to use some metrics to manage their system and how this kind of device could be, in the long run, could be transitioned from the active mode to passive mode. One of the, let's call it, in order to go toward details of this kind of problem, we would like to address the first problem as comprised of two sub-problems. The first sub-problem, we would like to think about and discuss about a commodity hardware temperature. So and you can see, we tested in a real test bed, and and I can show the slides, the details of the slides in the next slide. We will see that the change in the transition, it counter effect, and it has side effect of the temperature of the system, and it will distribute the temperature heating situation over other component in the network. On the other hand, we go for a generalized case, for a large scale case, and we tested by we tested as a simulation in over an ISP network with a huge amount of commodity hardware inside the system. So let's start by first sub-problem of the problem number 1. As you can see, we would like to talk more about the commodity hardware, and we would like to talk about a real measurement on simple test bed we test over a commodity hardware type we address in our solution. In this problem, the commodity hardware that we would like to talk about is a server. So we have one server. This server could be turned on or turned off. And so to be simplified, it could be in the active mode or in the sleep mode. And you will see that by changing the state of the server, the system could produce a lot of heat, and it could be side effect in whole of the network. And you will see that by abrupt stopping of the fan over the CPU and RAM of this kind of server, it could be spread the heat over the components and increase the temperature transient before reaching the steady state. Steady state means when it wants to, it would like to go to the state that it could be. In the transient case, it increases the heat in the system, and it side effect in the whole of the system, and it causes a failure rate in the system. So the failure rate, it tells us to change that kind of server in the long run. Let's see the test bed. So as I explained before, we use one server as a type of the commodity hardware for our experiment. We use a ID rack interface, which is installed over a commodity hardware installed over a server in order to measure the temperature of the system, of the motherboard. And we use a power meter in order to measure the power transmission of the commodity hardware. And also we use two thermal cameras, one over a RAM and one over a CPU. And we analyze the situation of the temperature on them. And we saw that these are the other details of using the switch and Ethernet in order to analyze these informations. And here is the testbed hardware we use in this first type result. And here are the software, let's call it software code, in order to obtain the hardware power consumption and the CPU temperature from the system. So in the first result, I just want to say before starting the plots to you that we have a lot of plots. I just try to select some of them in order to show and give idea about the general scope of the problem. And if you're interested to more information about the work, you can go toward on the details of this kind of papers, which are written, the titles, and the details are, you can access through the information that it will appear at the end of this slide, at the bottom of this slide. So in the first figure, you can see about the changing of the active mode to passive mode. In this slide, you can see that the CPU, the server power, when it was in active mode, it will appear in this shape. After that, when it goes to the sleep mode, it's obvious that the power consumption immediately goes to 0. But you will see that the CPU temperature cannot go immediately to 0. It tries to decrease in such a way to reach to the steady state. It means that try to spread out the temperature to the other components in the system. And here the ambient temperature is the temperature of the room that we are testing. For the next plot, we also test the system for different load. We give different tasks, different process to the system. You will see that by increasing the process of the system, it's expected for all of us, the power will increase, and the same, the temperature for the CPU will increase. This plot, this slide is talking about the time that we turn the CPU off in sleep mode. So you will see that each 10 minutes we use a camera in order to record the scope of the situation. This is running over the CPU. And we will test the CPU in 4 different spots. So due to the sake of the time, I don't explain about the spots, why we select the spot and how we select this one. So in order to get more information, I just advise you to go toward the paper to know more about the details of the selection of that one. And you will see that I want to show in these 2 plots that this is for over the RAM. You will see that by increasing the time that device is in a sleep mode, the heat could be distributed over the other component inside the motherboard. So, by considering this point, we try to propose a metric in order to control the device. So far, it's a normal case happening in the system. So, we would like to propose a parameter which is called Accelerator Factor. We use this kind of parameter in order to analyze the system and try to, let's call it, to give us more information to the monitoring devices to understand that when and how we could change the state of that device that we are targeting. In order to care about that one, we try to use an accelerator factor, which is combination of the changing of the frequency of that device based on the interface case for two states. One, it's in the state number 1, goes to the state number 2, and one, it's back from the state number 2 and come back to the state number 1, plus the transition time or transition duration it takes to cover in this, to be in each of these states. So we just want to highlight that accelerator factor, it's calculated for it could be calculated for a long run, not for 10 minutes, for 20 minutes, for 1 day, assume for 1 day, or for more than that, that cases. So that, as you can see, we test the system by considering this parameter, and you will see the result of accelerator factor in these vertical values. And I just want to highlight that if we try to keep the accelerator factor less than 5 in 1 day, we could guarantee that less than 20 transition on that specific server, it costs to keep the temperature of that device less than 20 centigrade. The rate that it could be, let's call it a balance rate and assurance rate for us to keep that device for a long time. By considering this point, we go to the second solved problem, which our aim, which is coming from the transaction paper, which our aim is going to address the lifetime of the general scale problem. In this scale problem, we don't address just one commodity hardware. We have a group of commodity hardwares. It could be different servers inside the network, or just different ISP network inside the network. So each of them, they communicate to each other. So we have a graph of communication of the commodity hardwares. And our aim is to minimize the average accelerator factor over this network. So I skipped the mathematical solution. I just want to give you the general scope of the idea. So we just give a set of the commodity hardware, switch the system, the connection, and the various traffic. So it could be worked with different shape of the distribution of the traffic in the system. We also test it. You can see in the next slide. And it could be based on the limitation of the network. So you know that each link between the two commodities hardware that are communicating to each other inside the network, they have a link utilization, maximum link utilization that they could tolerate. So we also consider these boundaries for each time slot. I just want to highlight that we try to resolve the problem online. You know, this concept is good for the guys that they work in an analytical aspect. It means that we just want to address the problem exactly in this time slot we are discussing now. We don't talk about in the long run. So we would like to address the system slot per slot. After that, we would like to calculate the result per slot, and the outcome of this slot would be sometime, it could depend on the problem, could be as an input parameter for the next slot. The same as the multiple iteration that you calculate in your machine learning. And we test this result with two different, let's call it in this paper, with two different shape of the network for a flatted tree and that type of the network, and these are the criteria and the characteristic of the network. And in order to speed up the process, we propose a suboptimal solution, which is, we call it AFA, and compare the solution between each other, that one and the optimal solution, with different sub-scenarios. And we have these results, as you can see, that even our heuristics tries to reach to the average accelerator factor, which is the optimum of our solution. For the next slide, which we would like to address, that you will see that our heuristics approach compute the result much lower than the optimal solution. So it gives us an idea that we can apply these techniques, especially the heuristic of this one, in the long scale, in the long run, and the long, the number of huge number of the commodity hardware engaged in the network. And here are the other cases for the various hardware parameters. We tested other. So these parameters are, all of them are described, that these values coming from which let's call it which data set and which real devices. So I try to ignore about this kind of explanation. So let's go to the problem number 2. So far we understand about the commodity hardware, different states that affect on the side effect of the network, and the changing of the state of the commodity hardware could be managed, could be controlled, and this is one of the points for the attackers in order to get decision and try to use for themselves. By considering this point, we go to talk about the mutual costs that happening in the cloud data center. We would like to talk about, we would like to address this case, that the cloud data center could be another type of commodity hardware, which is comprised of a set of commodity hardware, set of servers. In order to talk about the problem number 2, I just want to recall some of the, let's say, general concept that you know. The data center is intensively widespread all over the world, so doing a lot of applications. You can process a lot of applications, a lot of tasks. You can do streaming over this kind of devices inside the network, and it could be used in cloud storage. As you know, data center is one of the commodity hardware, so it could be in active mode or passive mode. And also it could be in active or sleep mode in our situations in order to reduce the energy consumption and the electricity usage. I just want to give you about just the prolific background of this kind of work is the originate work coming from my PhD 2 years ago, but this work is completely emerged in this year. And we would like to talk about the transition between the active mode and sleep mode in a long-term period over a system. I just want to say that each server inside the cloud data center could be in active mode or sleep mode. We would like to see the situation over a cloud data center, a huge amount of the servers in the system we have, and each server could change the states. But we should note that we would like to see about money. How much money content providers or data center providers should spend in order to take care of this parameter, in order to take care of the accelerator factor of their servers. So they would like to know that until, let's call it, until how many transition, how many period they can keep this server working. Otherwise they can change it. So this provides for them a cost. It calls it maintenance cost. So maintenance cost caused by increasing the failure rate inside a system. So each server could consume a failure rate, and by increasing the failure rate, it increases the cost of changing that device, the cost of maintenance cost. The second problem that the content provider and the data center providers are engaging with is consuming less energy for their device in order to provide a green situation and so on. So let's simplify our model in this problem as this plot. We have different physical servers in the physical servers in here, and each physical server using a hypervisor over each physical server in order to communicate with different virtual machine and running different virtual machine inside the system. So this is the general concept of the center, you know very well. And you will see that the group of the physical server connected with the switch, and the first layer switch and the second layer switch, and it could be considered in each pod, and the group of the pod could communicate with a data center network core switch, and all of them could be connected with a network manager component, which task is to manage the whole situation, manage the whole services coming to the data centers. For example, it could be considered as a software-defined switch, it could be considered as other type of a switch, or normal switch. So the network manager's task is to control the services coming to the system in order to span it, in order to split it to the available pods in the available physical servers and virtual machines running in the system. So in order to propose this kind of techniques, network managers should use some algorithms, some solutions, some ways, some techniques, some methods, that all of them are considered in allocation manager. In this problem, we address the proposed joint solution that it could provide a load balancing and a scheduling of the virtual machines that they can run in physical servers in such a way to decrease the energy consumption of these devices and decrease the number of the migration that this virtual machine, for example, from this physical server wants to migrate in that period of time to the other physical server, whether in this pod or other pod in the system. So we have different energy consumption, different parameters considered in one type of the problem. And the second part of the problem is the problem of each physical server. How many times they can change their modes, as I explained in the previous problem. So these are a joint problem, is a nonlinear problem. But I just want to give you a general scope of the descriptive outcome of our formulation. So we propose an optimal maintenance and electricity cost solution, we call it OMEC, which our target is to minimize per slot the maintenance cost and electricity cost. Which electricity cost comprise of three parts: the cost of computation of each request inside each physical server, the cost of migration, minimizing the cost of migration of the virtual machine from current physical server to other physical server, whether it could be in one pod or other pods, and the communication cost between these two virtual machines. Respect to some of the boundaries we have in our system, the capacity, maximum capacity of CPU, how many virtual machines it could be received. This is one of the boundary we have. How much memory do we have in order to we can reside different virtual machine on it. These are some of the limitations that I described this kind of situation in this slide in order to get more information about a solution of each of them and the detail of the mathematical outcome. I advise you to go to visit this kind of paper. And I just want to show some of the slides in a specific case that, for example, in this problem, in this plot, we have 5 servers, 15 virtual machines, and 1 year run. So we have 1 year time slots. So each time slot is it's completely extracted from the reality, the data, and we test this situation over cloud data center for 1 year run. Each time slot is around 15 minutes, so we have 35,040 slots that we test the system, and these are the outcomes. So what OMEC said, OMEC is our approach, and these two approach are the basic approach are available in the environment. We will see that majority of the events, majority of the slots in our solution compared to the other ones consume use less migrations. It means that we try to not only keep the maintenance low, but also we try to decrease the number of the migration between a changing virtual machine from one physical server to other physical server. The next plots are talking about the various parameters. Okay, here is the same, let's call the same test that we discussed about 5 servers and 15 virtual machines. And you will see about accelerator factor and the cost that it caused by accelerator factor. You will see the different situation in our outcomes, in our result compared to the other solutions. And in this plot, you will see the changing of the electricity cost and compared to the maintenance cost and the total cost with various cases that is illustrated with various shape of the networks. So let's back to the last problem, which we are going to address the software, the service function chaining. So these are some of them that I just want to give you general scope, a general idea about the service function chaining. So the guys that they're working on software-defined networking and the network function virtualization, they know this concept very well. So I just want to give it very fast about the definition of some of them. So you know the software-defined networking is one of the powerful infrastructure right now is working in the recent network environment. And the service function chaining is the chain of the network function, a group of the requests that it could be served per flow in the system, is one of the critical points that right now Cisco, Google are targeting in. So we would like to go first on the system architecture of our model, which is coming from this paper. It's available in archive right now if under review in this transaction paper. And the scope is this one, that we have a centralized software-defined controller. So it's clear so far. We have a southbound, they have communicating. That means that there are different software-defined switches. Each server are incorporated with each software-defined switch. So we consider these two all together in one node in our problem. And the software-defined controller could adaptively program different flow by using open flow inside each kind of the switches. Our target, our aim that we address in this problem is to propose two components inside the centralized software-defined controller to routing and rerouting the flows from one software-defined switch to their destinations. It could be whatever, any places. It means that each server or each user that connects to the server wants to do a specific task. It should make a flow from the source to the destination which is targeting for. But first of all, it should ask from the central controller from the and give the permission to this kind of device in order to find the destination and find the path for that one. This flow could be a normal flow, which is currently available, or a group of the flow, a group of the action it should be answered. It means that. Just want to give you a question, give you a very simple example. For example, we are one of the users. I'm here. I would like to access IDS and then firewall and then other services inside the system. So I send a request to this server. The server sends a request to the switch. The switch tries to ask the software-defined controller, should I give him permission? We assume that all of them are set. And the software-defined controller, by using a dynamic programming, they give the information to the software-defined switch that, okay, based on the follow table that it has, you see that this guy needs IDS, first of all, it should visit an IDS. We should visit a node that it has IDS service, and then it needs to visit the nodes that it has the firewall. According to the routing or the routing table which the software-defined controller it has, it gives that, okay, so the IDS is over here and the IDS is over here. But the firewall are not residing here, it's in here. So there are just one way to reach to this destination. It means that the server number one should send a request, make a flow, or make a virtual network functions, and send a request to server number two, and server number two should be visited, and then server number three should be visited. So it's a kind of flows that this flow specifically should pass from a specific destination. This is a current problem that they're engaging. So far is routing, it's not a problem. Assume that there is a failure here. We lose this node. What should we do? And who knows it? The software-defined controller knows this kind of situation. And the software-defined controller should find the path, other paths, available paths in the system, to give the request and response to the request of this user. So, of course, in this shape, we don't have the other paths in order to go, but we are discussing about a huge network, a huge sophisticated network. So we call this one a rerouting. So we know the situation happening in the system, and we want to reroute request from the source to the destination by using the other paths. So these are two different solutions, two different components are engaged in our problem, in our model. The first one, which is a common routing algorithm, we propose common routing algorithm in order to route the normal situation. And the second one, if we have a failure, if we have a congestion in the network, we should use a rerouting solution. The rerouting solution that it's really clear from your mind is that we have to find another way to reach that kind of destination. But we should take care about the SFC, take care about the set of the function we have to take into account. So by this kind of concept, we propose some solutions. So we propose some. So first of all, this result is tested over a simulation, and now our team in CNIT is working on a practical one in a small, let's call it small testbed, and then goes to the larger scale cases. Before I say the question, I say this one. So and then we would like to. So our aim in this specific, let's call it paper, our aim is to minimize the total energy consumption of the servers, respecting to the maintenance cost we have. So here is an optimal network reconfiguration problem that we are targeting minimize the energy consumption of the servers for each time slot we have. And here are the constraints, follow conservation constraints, server utilization, and virtual network function and service function chaining constraints. We test the system, we test the solution in this hardware. In order to speed up the process, also we propose some heuristics to reach to the suboptimal cases with a very, very fast convergence. So we tested the systems in abelian network topology, which is one of the trusted topology we can care about our system, our model, and test our model over it. So there are 11 switch and 11 servers, software-defined switch are residing in the system, and we test on over this kind of network our solution. So you can see that in the plots, so our approach is ONR, our heuristic is here. You will see that average path length in our heuristic is much less than that one. So it's really, really appealing from huge case. It means that we can find a solution not only faster, but also try to use less or try to consume less channel in each link in order to keep it again available for the rest of the flows in the system. I just want to highlight that we test the system over 10,000 flows, 10,000 different shape of the flows. And here are the link utilizations and server utilization of the outcome for different runs and different scenarios we have. And let's conclude our discussion. So as you know, for the problem number 1, we have performed a measurement campaign over a commodity hardware server to take care about a temperature. And we would like to see about the situation. We propose Accelerator Factor in order to control the state of the commodity hardware inside the system. And in the larger scale, we show that the lifetime, it could be varies in the time, but the different Accelerator Factor, it could be managed over for each commodity hardware switch. For the second problem, we take into account the commodity hardware jointly maintenance cost and electricity cost. We propose the optimal solution, and we test it in the system, and also we address the CPU processing, transfer data, and virtual machine migration. And the last problem, which recently I discussed, talking about the SSC over software-defined network switch in order to reduce the overall energy consumption. So the problem is integer linear programming. We try to solve it in a normal case, and but for the larger scale, we decided to use heuristics, and we take into account different quality of services, power consumption, average path length, and link and server utilization. For the future direction, let's call it our group CNIT, right now propose some proposal for the European project, and which target for the much sophisticated scale of this kind of problems. And we also can take care of multidisciplinary security issues in this problem. So you can assume that we can think about using blockchain in the second problem. We assume that we have geographical cloud data centers in different places. And what is our aim? Our aim is to decrease the money, less spend money. So we have to use a distributed open ledger in order to control that disciplines from the economical point of view of the point of the broker that they're using, that they're serving the request over each cloud data center. This is one of the topics that right now Cisco and Google are working on them and proposing some solution by such as segmentations over software-defined networking, how to manage SFC over segmentation in software-defined network. This is the thing that we are now working on it. And so I need your suggestion for the last point. Any other suggestion you have in your mind? I will be really appreciated. And thank you very much for listening. And some of our emulations, some of our results of our source code are available in our project, which is coming from Superfluidity project. And so these are the references that I taught. And I will be happy if you have any question. Most welcome.
Thank you very much. I'm sure we have a lot of questions. Hassan, you have questions?
Regarding that, what you were said about the future of blockchain and you were trying to build out. So what would be the aspect regarding the elasticity and the computational head and the it's not a question, just I want to...
Yes, right now, so this is coming to my mind because as far as I know, right now my colleague Claudio Pisa is working on it, that we are thinking about how we could integrate, especially the last problem, or maybe the second problem, the cloud center, you saw it, in a geographical environment. So we have, for example, the cloud center in here, one in Germany, one in other places, okay? So we would like to think about proposing a, let's call it a distributed solution.
And you used the word blockchain.
Yeah, exactly.
I was I was thinking about like what you have in your mind regarding the elasticity of the blockchain and the computational effect.
Not exactly. We would like to apply blockchain. Let's call it like this. We would like to use, as far as I know, because I'm not a security man, so of course you're better than me. I just want to give the idea about it. That the blockchain, so let's call it, we are going to use a distributed open ledger, different environment, and we would like to use different sessions. So each session between two cloud centers, two different places, could cost. Why? And why it could be a cost of that one? Because if each session is coming from the traffic coming to the centers. So I'm a cloud center provider. Okay, if I receive this traffic, does it affect on my money, on my pocket or not? And the money I will receive from this traffic, it could be, let's call it benefit for me or not, based on the problem which I have in my cloud center, for the energy consumption, for something like that, okay? So these are like a game. So the traffic comes to the system, so there are different cloud data centers, different places. So there should be a broker or there should be a distributed policy in order to see this traffic could be managed by the cloud data center number 1 or number 2 or number 3 or number 4. So these are the game theory competitions. So one of them, they catch the point, so all of them, let's say, the state table of all of them will be updated, but one of them will be benefit of that kind of situation, the cloud center. So these are the, let's say, general concept of the distributed open ledger, but in the blockchain situation. So we would like to think about, not we, I mean the Cisco is working on it. But Cisco is working to proposing a solution, proposing a framework, let's call it like this, to use this technology, the blockchain technology, inside the cloud center because of money.
Yeah, it's a question related to problem number 3.
Okay.
Which is like service function chaining over SDN. So I am working on a similar problem. I mean, I'm trying to figure out how to do it. But you talked about, let's say, in your simulation or in your experiments, did you consider the case when SFC has already been set and a failure happens after everything has been computed? Or
Nice question.
Or you, I mean, just consider the case when there could be a probability of failure and then you already, I mean, decided the alternative path.
Nice question. We propose a probability. We propose a probability, so we don't assume that okay, now we have a problem. No, we assume the system is working. Even the probability of the probable case happening by failure in each kind of switch, we can even handle it in online situations. It doesn't mean that the system now is failure. We will take you out because we address these two problems all together jointly. So it means that when the request, so we assume that. First of all, you should assume that you should consider that the network situation is set. Okay? So the system is okay. So it's running. But inside the running, even if the failure happens with any probability, okay, we're working, here is say bye-bye, here say bye-bye, and this time it's lost. So what should I do? I cannot route it because the routing, we miss this destination. So we have two choices. One, we should drop some of the flows because the destination is say bye-bye. So, or we should reroute and using some other way to reach the destination if the destination is available.
Okay.
Okay.
Can I mean, just one more question.
Mm-hmm.
Let's say how do you identify a failure has already occurred? Like.
Yes, because it's a random case, at least for the simulation. Okay, for the simulation point of view, it is random. For example, we said that for the random case in this time slot, for this 11 switch from that network topology. For that 11 switch, okay, switch number 4 in 80% is done, is the failure, goes to the failure, okay? So these are the probability in each time slot we added in the system. Of course, it could be even managed. We didn't manage this one. Our target was to, let's call it, to routing and rerouting the process. We don't think about, it's a really nice question. I also have in my mind, I have to talk with my team, to specifically, how can we tune that kind of failure? We assume it's random, just this, in the simulation. Even in the reality now we are testing, we are, let's say, my team, the practical guys are working on, in a random case, that it happens. Doesn't mean that I should target exactly this one. It's a really nice question.
Because this has
even for the attack, you can target that one. So we didn't let's call it address that one, but it's really of interest that we can work on it.
Because this has not been. I mean, nobody says in any paper so far I have read, like failure at a particular node, and then what will happen, or will it be just downtime until the system recognizes it?
Yes, it depends on the situation of the system, and in our solution, we target it as a random, and it's nice. We can think about other cases that you have in your mind.
Sure. Thanks.
There's a question from the streaming from Mohammad Akenari from University of Rome Tor Vergata. And he asked if there is any way for an attacker to change the hardware state of a node, I presume.
Well, from that, okay. I mean, you're talking about the last problem, maybe, or no, general scale question.
He doesn't specify.
Oh, okay. So, yes, of course. So, when the attackers come to attack any devices, so honestly, these problems that we address in this slide, we didn't target specifically about the attack types. We just talk about the different problems and different possible attacks may be happening on each of the kind of the problems. So of course, the response to the question, it could be definitely the attack could affect on the hardware, so, and we didn't let's say anticipate it in these models.
Thanks.
Thank you. Other questions? Okay, and let's thank the speaker. This also concludes the workshop, so thank you all for coming. It was a nice interaction. See you in the next